Dark matter is often seen as a mystery, the mythical substance holding our universe together, the ancient, invisible particles that could be pelting our planet without us even knowing, the scientific golden topic to study, or well, that's how the news stories tend to paint it. But while those might seem a little exaggerated, the history of dark matter research is still incredibly interesting. Now get ready, because we're going to move fast here. First off, the existence of dark matter is a relatively new concept. There were a few philosophers and scientists between the 17th and 19th century with ideas that were on the right track, such as, is it possible for an object to have mass without emitting light? Which nowadays sounds kind of like our description for a black hole, but it also aligns with the concept of dark matter, although it's a little simplistic. Yet the first scientist to use the term dark matter, and a definition that aligns with our current one, was Fritz Zwicky in 1933. Now, you might be saying, 1933? Isn't that like 88 years ago? That seems like a long time. Well, for some context historically, Scotch tape, the everyday household item, was invented in 1930, and the Queen of England was born in 1926. That doesn't seem like that long ago now, right? However, Zwicky's theories on dark matter, or Dugumatri, as he called it, were ridiculed and quickly forgotten by the wider scientific community. But don't worry, he'll show up later. But now we're going to jump to the 1970s, when astrophysicist Vera Rubin and her colleague Kent Ford, while using Doppler shifts to find the orbital speed of stars in various galaxies, stumbled upon evidence that the stars further from the center of their respective galaxies weren't behaving as expected. Instead of orbital velocity decreasing as the distance from the center of the galaxy increased, like how the Earth moves a lot faster than Jupiter or Neptune, which are because they're further from the sun, the orbital velocity of these far-off stars were actually staying relatively consistent across the galaxies, across far greater distances than should have been possible, suggesting that either the fundamental properties of physics were, as they were currently understood, incorrect, or that there were massive quantities of an unknown force having an effect on those stars. And after studying over 50 more spiral galaxies, Rubin and Ford determined that these galaxies must have had about 10 times as much mass as could be accounted for by visible stars, which led Rubin to remember learning about Zwicky's findings when she was in graduate school, and to realize how similar they were. Nowadays, it's estimated that dark matter actually outweighs visible matter at more of a 6-to-1 ratio, but we still don't know what it's made of, just that we're running out of ways to search for what it is with our current levels of technology.